Talking about moving around a file using ftel, fseek, and rewind. So I quickly showed you some examples of using ftel and fseek and rewind. If you read the documentation on one of the sources that I cited at the beginning of the course, the documentation is really confusing. And so it says here, if the file stream is opened in binary mode, the value obtained by this function is the number of bytes from the beginning of the file. So that kind of makes sense, right? So in the last lecture I said ftel basically gives you an index into the file, right? But the documentation goes on and says if the stream is opened in text mode, the value returned by this function is unspecified, only meaningful as the input to fseek. And so in Linux, you can ignore that second line. There is no difference between opening a file in binary mode or opening a file in text mode under a POSIX compliant system. Right? So that doesn't matter. So you only care about the binary stream stuff. They're the same thing in Linux. So there is no difference between opening a file in binary mode or in text mode. The text mode stuff is for Windows, because Windows does something funny with the encoding of new line characters. All right, so so we saw rewind. So this one goes back. This one is the one that keeps on. OK, so fseek. So fseek lets you move to a position in the file. So you pass in a pointer. Whoa, sorry, this stupid computer. You pass in a pointer to the file that you are reading or writing to. You pass in something called you pass in an integer value called the offset. And then you pass in another value called the value here called the origin. OK, so the relevant part is if the stream is opened in binary mode for us. Right, so the offset is basically the number of characters relative to this position. Okay. So the origin can be seek set, in which case the position or the offset is relative to the start of the file. The origin can be seek cur, in which case the offset is relative to the current position. Right? And then the origin can be seek end, in which case the offset is relative to the end of the file. And binary streams, so streams in Unix are not required to support seek end. So seek end doesn't necessarily work for our purposes. Right? So if you pass in 0 for the offset and an origin of seek set, that is the same as rewinding the file. If you pass in an offset of 0 and origin is seek cur, then that does nothing. The file position stays the same. Right? So if seek cur is, you pass in seek cur and -1, that backs up one character. Right? And if you pass in 1, that moves forward one character in the stream. Right? So the following file just uses fseek to move to a specified position, POS, from the start of the file. Right? So if we, this is, sorry. Oh. OK, so this is going to be seek. OK, so it asks you what position you want to seek to. So we'll say 0. That should put us at the start of the file. So that should be the A. Right? So remember our file is A, B, C, D, E, new line, F, G, H, I, J, K, new line, and so on and so on and so forth. Right? So 1 should be the B. 2 should be the C. Right? 20, I forget what, 26, 23 should be the last character. No, 22 is the last character in the file. So that's the T. Right? Notice at 23, it actually printed out the new line character. So that's the new line character at the very end of the file. Right? Oops, how do I quit? Control C. OK, there we go. All right, so so you can jump around a file using fseek if you want to. Now, if you open the file in one of these plus modes, that lets you read and write to the file at the same time. Right? So you can use any of the functions that write to a file, and you can use any of the functions that try to read something from a file. Strictly speaking, you're not allowed to write to the file and then read from the file without calling one of these functions first. That's just to make sure, that your stream, for buffered streams, it's no longer being buffered when you make the next read. Right? And similarly here, you can't read from the file. Input cannot be followed. You can't read from the file and then write to the file, again, without calling fseek, fset position, or rewind. And again, that's to make sure that the file position is updated properly in case any buffering is happening. All right, so this little program is going to try to replace every occurrence of a character inside of a file. So it's going to open up the file in update mode. It's going to scan the file one character at a time using fgetc. It's going to look at the character that it reads in. It's going to check, is this the character I want to replace? Right? If it's the character you want to replace, it's going to back up one position in the file, right? Because after you read a character, it moves forwards. Right? So we're going to back up one position in the file, replace the character that we just read, and then move to the and then continue. Right? So the program name is called replace car. It takes in a file name. Right? It takes in the target character, so that's the character you want to replace. And then it takes in a replacement character, so that's the character you're going to replace the target with. So we're just going to read the file one character at a time using fgetc. Right? So there's the usual loop using fgetc. Right? We're going to look at the character that we just read in. So if it's the character we just read in, I want to back up one position from the current position. So we use fseek to go back one position from the current position. Right? And so that moves me back to the character I just read in. That moves me back to the position of the character that I just read in. And now I can replace that character using fputc. Right? Technically speaking, you should flush the stream here to make sure that the write actually happens before you try to read it again. Although this seems to work on my computer. I think I fixed it on the actual program here. Yeah, so I do have the flush here now. And so if you run this, so we'll look at the file temp2. Right, so again, it's just a bunch of random quotes that I got from the Fortune program. And so I'm going to go in and replace every, I guess, E with a symbol of some kind. So replace car, temp2. We're going to replace every E with some symbol of some kind. So let's do the $, like that. Right. So it does its thing. Right. And then, and if we did everything right, every E is now replaced with a $. Right, so it reads and writes to the same file at the same time. It reads and writes to the file at the same time. Okay, so that lets you replace a single character in a file, but unfortunately, that's all that you're limited to. Right? So you have to remember that you're basically viewing the file as though it were a big array. But there's no way that you can insert into the middle of this array. Right? So all you can do is you can read elements in the array and you can write elements in the array. Right? So if I wanted to insert a new character somewhere into the file, it can't be done using these functions. Right? Similarly, if I wanted to delete a character, right, and then shift everything forward in the file, you can't easily do that either. Right? You'd have to do it all manually, which is a huge pain. Right? So I can't take that code that I just showed you, and instead of replacing a single, and when I replace a single character, I have to replace that character. I can't change it to some sequence, to a string of more than one character, or I can't change it to the empty string, right? So delete the character. But it seems like these are things you might want to do if you're dealing with files, right? So if you are trying to do this sort of thing, and you wanted to write this on your own, right? And then the way you would do this is you have a few options, right? You can read the entire file into memory, right? So read all the contents of the file into an array, right? Perform the required end deletions that you want manually on the array, and then write the array back out to the file, right? The other way to do this is you can read from one file, right, and then write to another file at the same time, right? So instead of overwriting the original file, you can send the contents of the new file, of the updated file, to a new file somewhere else, right? So that works just fine. The problem, of course, with this is that you end up with a second file, right? Whereas you might have wanted to replace the first file instead. Right? And so the other solution is to find some program that's already written for you that will do the insertion and deletion for you. Right? And it turns out there's several well-known text stream editing programs in Linux or in Unix. Right? OK, so that's all I want to say about fseek, ftell, and rewind. I guess for your assignment, though, which was supposed to come out on Monday, but something happened. It's going to come out later today. You need to be able to read, or you're going to want to be able to read formatted data from a file. So instead of reading stuff character by character, we want to read in chunks of information. Right? I want to read in an int or a double or something else, or a string or something. Right? And so that's the contents of today's lecture. All right, so a lot of different files that you have to deal with are line-oriented. So many of the files you have to deal with are formatted but not line-oriented, right? So most programming languages are not line-oriented, right? So they're construct-oriented, basically, right? You don't so the techniques I'm telling you about here aren't going to work to read in those kinds of files, right? If you want to read in a programming language or some other structured data, you have to parse the data. And that's something that's not usually taught anymore in most undergraduate curriculum. It used to be something that you were always taught, but it's no longer considered fashionable. Right? If you take the compilers course in 4th year, you might have to do it, but otherwise you're probably not going to see it at all. You can click on that link there if you're interested in parsing or how parsing of languages works. Right? So instead, I'm going to read a file where all the information is on separate lines. Right? And each line is supposed to have a certain structure. Right? So there's this file on every Unix system called password. And it lives in the etc. directory. A long, long time ago, this actually used to store the password for every user. And surprisingly, it would store it in plain text. Right? So not encrypted. But that was a very long time ago. Now the password file doesn't actually store any password information, but it's still used for some basic information purposes. Right? So it's essentially a really, really simple database. It contains very basic information about the users on your system. Right? It's in plain text, so anybody can read it. Each line represents a single user. And every line is supposed to have 7 fields separated by colons. Right? And so that's what one line of the password file looks like. Right? So the first field is the username. Right? Then there's a colon. Then in the bad old days, your password used to be in the second field. Right? Now, for the most part, there's just the letter X here. So there's just an empty placeholder. Then there's a colon. Then there's your user ID. So this is just an integer number that corresponds to your UID. Right? Then there's a colon. Then there's an integer number that corresponds to your group ID on the system. Then a colon. That field there is called the GCOS field. I don't remember what GCOS stands for, but again, it's very old. Right? It can contain anything. So it can contain any miscellaneous user information. It might be your phone number, it could be your room number in your office, it could be a phone number, et cetera, et cetera, et cetera. Right? So it could be anything, but there can't be a colon here because the colons are used to separate fields. Right? Then there's a colon, that's your home directory. Colon, that's your login shell. So that's the shell that you get when you log on to the system. And so that's an example of one record in this file. Right? So everything is separated by colons. OK, so if you wanted to read the contents of this file and process each record as you read it, right, there's lots of ways you can do this. Right? So you can read the file one line at a time, and then break the string up using strtok or using scanf. Right? So let's try to break, so we looked at strtok, so let's try to read the contents of one of these password files using the string tokenizer function. Right, so that's in the file password.c, which is on the website, which is on OnQ. Okay, so to do this, I'm going to define a record, a structure called record. Right, so record holds it holds the 7 fields for the that are in each line of the password file. Right, so there's a string, that's the username. Right, there's a string, that's the password. UID and GID, so those are unsigned int. Right, and then the string for the user information, their home dir and their shell. Right, notice that I'm not using arrays of car here. I'm actually using pointers to car, so we're going to have to allocate memory when we store this information in the record. Here's copy string. So copy string copies a string source, right, into a new string called dest. But it's a little bit more fancy than that. Right? So instead of requiring the user to supply an array that's large enough to hold the source string, this function allocates memory allocates sufficient memory to hold the contents of the source string. Right? So notice here this is a double pointer, right? So pointer to pointer, which we saw a few lectures ago. Right? And so someone is going to pass in the address of a pointer where they want to store a string. Right? This function is going to change that pointer so that it points to an array that's big enough to hold the contents of the string. Right? Length, that's actually a mistake. That's length plus 1 because you need the null terminator. That was silly. All right, and then it's going to copy the original string into the destination string. Right? And then return, does it return? No, it doesn't return it, right? So the user ends up with a copy of the original string, and the user doesn't have to allocate the memory for it. All right, so here's the code that parses one line of the file. Right? So we read in each line of the file, and then as a string, and then we're going to try to separate that string into the 7 fields. So we make a record. And now I'm going to use strtok to try to find the first field of the string. Right? So remember, the way you use this function is the first time you call it, you pass in the string that you want to tokenize. Right? You pass in the character that separates the fields. Right? And this thing returns a pointer to, in this case, the first token or the next token in the file. Right? So hopefully this returns a pointer to the person's username, to the user's username, right? It returns null if it fails. So if it returns null, we're just going to bail, right? So we're just going to say we can't parse the rest of the record and return what we have read so far. If it doesn't fail, we're just going to copy whatever that string is, whatever that field is from the line we just parsed into the username, right? So remember, the username, that's a pointer. Copy string requires a pointer to a pointer, so we need the address of that pointer, right? And then copy string will allocate memory for the string and copy it into our username, right? And now you proceed, right? So you call strtok again, right? You pass in null to indicate you want to continue parsing the previous string, right? And if it returns if it doesn't return null, you end up with the password. Right? So we copy the password into the record. Right? And you just keep on going. Right? So now you call strtok again. Right? If it succeeds, you've got the user ID. Right? And so I'm going to use a to I to convert the integer value. The string, I'm going to use it to convert the string to an integer value. Right? And store that in the user ID. Right? And we just keep on going. Right? So it's all the same stuff over and over and over again. So you just process each field one at a time. Right? To print a record, right, I'm just going to print out the 7 pieces of information. Right? Okay, so our main function, all it does is it opens up, etc. password for reading. Right. We're going to assume that each line is relatively short, so I'm making the assumption that each line is 100 characters or less. That may not be a good assumption, but for the purposes of this example, it's fine. I'm going to use fgets to read in each line. Right? So remember, fgets is the function that reads in a string of that many characters minus 1 at most. Right? So it'll read in most 99 characters and store those characters in that array. Right? Then I can parse that array using our parse record function, and then I can print each record as we go. Right? And so let's see what happens when we parse my etc. password file. So first of all, let's look at etc. password to see what's actually there. Sorry, cat etc. password, like that. So you can see there's quite a lot of users on my particular system. Right? And so Unix and Linux systems tend to do this. They tend to make lots of users for system processes. Root, that's the system administrator account. Right? My account is down here. Right? I made up a user called Homer Simpson, so their account is right there. And there's a bunch of other stuff here as well. Right? But you can see each line seems to have the required format. Right? Some string, colon, some string, colon, some string, colon, and so on and so on and so forth. Okay, so let's see if our little program can read that file successfully. So that's password. Oh, sorry, wrong directory. But where is this? This is in Okay, so let's see what we get. Okay, so when we look at the output for the first user, it looks correct, right? We have a username, a password, a user ID, and so on and so on and so forth. Right? If you keep on scrolling, everything looks fine. Right? It's fine. Right? Right? You keep on going and you look and say, yeah, this seems to work. It's okay. Right? But if you pay, eventually you reach a point. Hopefully, oh no, I haven't yet. Right? You reach a point when you get to the message bus user. Right? And you look at the output. Everything seems fine until you get to the shell. Right? So you should get the home dir, and then you should get the shell. Here we got a blank line, and when it prints the shell, we get some gibberish. Right? And that doesn't look right. So there definitely wasn't any funny-looking characters in my password file, and so something has gone wrong at this point here. Right? And if you keep on going, you'll see that there are similar errors. Right? So syslog also has a funny shell, right? And who's this user? apt has a funny shell, and so on and so on and so forth. Right? So something's gone wrong. And so if you actually carefully look at, the password file, right? And you go and look at the, what are they? They're the message bus. Here it is. And you look at this line, right? So there's a username, so that's good. There's a colon, there's an X and a colon, a number and a colon, and you run into this problem here. Right? There's an empty field. Right? So the GCOS field, the user information field, is blank for this particular entry. Right? And string token, strtok, doesn't deal with blank fields. Right? If it sees two delimiter characters side by side, it treats it as though it was a single delimiter, right? And so it thinks that there's no field here, right? Even though it's an empty field. So if you're in the situation where your fields can be empty, you can't use strtok just the way you would normally use it. You have to do some extra work. So one of the things you could do is you could try to fix your code, right? So you could try to update our code to see what happens. So just to explain what's going on here, right? We have an empty field here, right? The way that strtok works is it inserts the null terminators, right? It replaces our delimiter characters with null terminators, right? So that colon gets replaced with \0. That colon gets replaced with \0. When we read in the 1000, right, it replaces the next colon with the \0. Right? When it tries to read in the next token, right, the way it works is it starts at the end of the string, so it starts here at the colon, right, and it looks for the next non-delimiter character. So it stops at the slash, right? But it's missed the fact that there's a blank field here, right? And so it reads in the, what is the next field? I forget the next field is supposed to be the shell. It's supposed to be the username. What is that? That's the GCOS field. So instead of reading in the GCOS field, it ends up reading in the username for the user information. All right, so let's try to fix this problem, right? You can't really, it's difficult to fix the problem in general, right? So here, because we know, or we're going to guess that it's always the GCOS field that's causing a problem, we can try to check, is this particular field empty before we call strtok on it, right? So let's go back and see what happens here. Okay, so here's where I read in the field before the user information, right? So this is the group ID, right? So we call strtok, try to read in the value, right? If we successfully read in the value, we try to convert it to an int, right? So we're now at this situation right here, right? So we've read in the int, right? strtok has replaced that colon with \0, right? My pointer, right, str, is this s right here, right? So it's the pointer to the 1000, right? I want to check, is the character after the end of this string, this substring, I guess, right? So there's our substring, right? Because there's our \0. Right? I want to check, is the character after that \0 a colon, right? Because if it's a colon, I know the GCOS field is empty, right? And so it's pretty easy to do. Right? So I'm going to write a function, is GCOS empty? Right? I'm going to pass in that string, right? So I'm going to pass in that string there, s. Right? And I want to check, is the character one past the end of the string, the colon? Right? So the length of the string I can get with string length. Right? If string tokenizer, if the strtok function has done its job, right, the character at s length is supposed to be the null terminator, right? So I'm going to assert that's true, right? If it's not true, my program will stop, right? Now, if it's true, then the next character I want to check, is that the colon, right? So that's the character at length +1, right? So if that's the colon, this thing returns true, and it says that the field is empty, right? If it's not the colon, then nothing's changed, right? S still points where it's supposed to be pointing at, and it returns false. Right? And so this program is password2, does successfully read in all of the records, right? So now there's no, if you scroll through quickly, you'll see there's no funny shell lines that get printed out, right? And so that gets around the problem of that one empty field, right? Of course, it makes the assumption that it's only the GCOS field that's empty, right? Really, you need to check, are any of the fields empty? But that's one way you can do it if you're going to insist on using strtok. Okay, so string strtok is a bit clunky as a function. One of the problems with it, so it's useful if you're just reading in strings, but if you need to read in other information, like integers, it's usually more useful to use one of the scanf functions, right? So you can use sscanf, that scans a string. You can use fscanf, so that scans a file, right? So you don't have to read in the stuff one line at a time. if you use sscanf, you can actually read in information one piece at a time, right? So using sscanf, I can read in an int, then I can read in a string, and then I can read in a double, and so on and so on and so forth, right? So with sscanf, you don't have to do line-oriented input. You can just read in individual pieces of information. They all work similar to printf, right? So they all use a conversion string. The conversions are similar to the ones that are used in printf. Right? The scanf family of functions, they all return the number of tokens that are successfully converted. Right? It returns 0 if the first token is not successfully converted. And it returns this value EOF if the string that you're trying to scan is empty, or if the string consists only of white space, and the current conversion is not %C. So I'll explain what that means in just a second. OK, so the way this thing works is you pass it in a conversion, right? Like %S, for example, right? So %S will try to read in a string. Most of the conversions will ignore any leading white space, right? So if you have a string that's space, 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 ABC, and you use the %S conversion, it will ignore the space, 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 and then read in the ABC. Right? So it discards all leading white space characters. Right? The conversion ends when it finds a trailing white space character or the end of the string. Right? And so things like %S, %S, %D for integer conversion, right? %F for a floating point conversion, right? They ignore the leading space. They stop attempting to convert when it finds another white space. Right? So white space here is the assumed delimiting character. Right? If it's important that you actually read in the white space, then you have to use %C, which reads in one character at a time, or this funny square bracket notation that I'll explain in just a second. With the scanf family of functions, you can restrict the maximum number of characters that are read. Right? So that's called the maximum field width. Right? So you put that in after the %sign. So %5S will try to read in a string, reading in at most 5 characters. If you use %S, so if you read in a string using %S, then scanf will always insert the null terminator for you on the end of the string. Right? Similarly with the square brackets. Right? Now, it will always insert the null terminator, but it assumes that the string you're reading the information into has enough space to store that string plus the null terminator. OK, so we haven't seen the square bracket conversion yet. So the square bracket conversion, it's %square bracket, and then there's a string in here. Right? So this thing matches any non-empty sequence of characters that are in this string. Right? So %square bracket ABC, right, will match any non-empty string made up of only the letters A, B, and C. Right? If you want to define the set of matching characters as the characters that don't match, then it's the caret followed by the string. Right? So that matches any non-empty sequence of characters not in that set of characters. Right? So not ABC will match any non-empty string that does not include the letters A, B, or C. Right? So it'll match X, Y, Z, for example, or just X or Y, Z, or something. Right? The non-empty part here is the thing that everybody forgets. Right? This won't, the %S and %square bracket, these won't match empty strings. Right? So you have to be very careful about that. OK, so if you want to match a string that contains spaces, right, it becomes really awkward, right? Because the scanf family of functions, right, if you use %S, it ignores the leading white space. Right? And then it stops trying to read in the string when it encounters a white space. Right? So if you want to read in the string ABC space XYZ, right, and it's important you read that in as one string, right, then you have to use the following, right? So that becomes your conversion, right? And so let's take this apart one character at a time, right? Because this is kind of hard to read, right? What exactly is that doing? Oh, so this is going to match a quoted string, right? So double quotes, some string that has spaces, just like you would pass in, just like you would type in bash if you were trying to pass in a string that has some special character in it. Okay, so what does this thing exactly do, right? So this is going to be my conversion string, right? So when I read in this information, I want to make sure that I read in an opening double quote, right? So I need to match the double quote, right? The problem is my string is inside double quotes, so I have to escape the first double quote character, right? So that matches your opening quote. That thing there, so I'm going to use the not, right? Backslash double quote, right? So this says match any non-empty string that does not have a double quote in it, right? So this includes the space, right? So this will read in a string that contains a space, right? Finally, I want to match the closing double quote, right? And so that matches the closing double quote. So that thing there will read in a string that looks like A, B, C, D. That, right? So match the opening double quote, match any string that does not contain a double quote, match the closing double quote. Right? Okay, so password 3, we're going to try to read using sscanf instead. Okay, so same structure for our record. Right, same function that copies a string for us. Okay, so parse record is going to change now. Everything I'm reading in is a string, right? So I need somewhere to store the read in string. So I need to assume something about its maximum length, right? Well, I don't need to, but I'm going to. Right, so I'm going to assume that every string in this record is at most 63 characters long, right? Remember, I need one for the null terminator at the end. Right. Okay, so the username, password, gcos, homedir, and shell, these are all strings. So I'm going to allocate space for these strings. Right. So I'm going to allocate a string of, an array of length 64 for each one of these. And now I'm going to try to use sscanf to read in each line, to parse each line in one shot. Right? So this is going to parse one line of our record, one line of our file that's stored as a string. So the first thing I'm going to try to do is I'm going to try to read in the first field. Right? So the first field, we're going to assume does not contain the colon in it. Right? So I want to read in a string that does not contain a colon. Right? So to read in a string that doesn't contain a colon, it's square bracket caret and then a colon inside. Right? I'm going to read in at most 63 characters. Right? So to make sure that it fits into my username. Right? So the first thing here, right, that first conversion, if it succeeds, gets stored here. Right? The second conversion gets stored in the password. Right? The third conversion, %u, gets stored into the user ID, and so on and so on and so forth. Right? So that tries to read in the first field. Right? Then it assumes that that first field is separated with a colon, so it tries to read in the colon. Right? Then it tries to read in the second field. Right? So again, any string that doesn't contain a colon, followed by a colon, followed by an unsigned int, followed by a colon, followed by an unsigned int, followed by a colon, right? Followed by a string not containing a colon, then a colon, string not containing a colon, and then a colon, and then string not containing a colon, right? So if our record is written correctly, then that line there should successfully read in all of the information into those pieces, into our structure fields here, like that, right? Okay, so this is, and then there's printing the record again, right? The main function is exactly the same. Read in one line at a time, pass it to our function that parses the line. So does this thing work? 3. Well, it looks a little bit better than the first attempt, right? When we get to message bus, right, it gives up after reading in the group ID, right? So notice that all the remaining fields are blank, right? Okay, so why are they all blank, right? So our functions, oh wait, do I actually do the, I do. Okay, so sscanf stops parsing the string when it encounters a conversion that becomes unsuccessful, right? So if we're in the situation where we have an empty field, right? So we have 2 colons side by side, and that happens right here, right? So that's the GCOS field, right? So it's going to try to match, right? So there's our colon after our group ID, right? Now the next conversion is any non-empty string that doesn't contain a colon, right? But we've got 2 colons side by side, so there is no non-empty string that doesn't contain a colon, right? So that conversion fails, and sscanf stops trying to do what it was doing, right? So it successfully converts 1, 2, 3, 4, right? The first 4 things, and then it gives up on all the rest, right? And so again, this also doesn't work if you have an empty field, right? Because that thing there won't match the empty string. Right, okay. Now sscanf, or all of the scanf type functions will return, or actually they have a conversion that tells you the number of characters read so far, right? So %n as a conversion stores the number of characters that have been read up to this point in the conversion, right? And so you can use that piece of information to determine whether or not a field is empty. So let's look at password 4 and see how that works. Okay, so this, again, this is specific to the GCOS field is missing, blank, right? So the way I'm going to do this is I'm going to try to read in the first 4 fields, right? So the username, the password, the group ID, and the user ID, right? So there's the colon after the user ID, and there's %n, right? So %n is going to store the number of characters that are read so far into the variable cars read, right? So assuming all of this works, right, that value there will be the total number of characters that are contained in the first part of our record, right? And I'm going to have that, and that information will be available to us right there, right? Scanf also returns the number of successful conversions, right? So there's 4 conversions here, right? So there's 4 % signs, 1, 2, 3, 4. Sorry, 5 there, I guess, right? So if the number of conversions is less than 4, I know that one of the first 4 fields was not successfully converted. So we're just going to give up here, right? All right. Now remember, I have the number of characters that have been read up to this point, right? So if I use that as an index, right, and look at the original string that I'm parsing, right, that should be 1 character after the last colon, right? So it's 1 character after that colon there, right? So if the next character is also a colon, I know I have an empty field, right? So the GCOS field is empty, right? So I can just write the empty string into the GCOS field, right? I can now take my pointer s. So s is a pointer to the string that I'm parsing, right? So I can now take that pointer and adjust it so that it points at the next character after the last colon, right? So take my pointer, right? Advance it that many characters, right? And then one more to go past the extra colon that's sitting in the GCOS field, right? And now I can parse the rest of the string using scanf again, right? So now I can correctly parse in the home directory and the shell. Right? If the GCOS field is not empty, right, then I just want to advance the pointer to cars red, right, and then read in the GCOS field, the home dir, and the shell. Right? And so this one also successfully, parses the file. Right? So if you scroll up to, where is apt syslog message bus, right? So now you can see that for that entry there, right, it correctly prints out the fact that the GCOS field was in fact blank, right, and then reads the rest of the information correctly. All right, and so that's using sscanf. The function fscanf is the one you're going to want to use on the assignment. So rather than reading in complete lines of information on the assignment, the way you should approach it is you should just read in individual pieces of information, right? So where necessary, read in a string, or read in an int, or read in an unsigned int, one piece at a time, using fscanf, right? So fscanf is exactly the same thing as sscanf. It just it reads from a file instead of reading from a string. Right? And so the assignment will have instructions on how to use that function to successfully complete the assignment. Right. Okay, so that's all I have for today. I guess what's going to happen? So there's a lecture on Friday. So there's one more lecture on Friday. And then next Monday, I hope to return quiz 2. And then I guess on the Wednesday, is that right? Wednesday, right? Yeah, and then next Wednesday will be the last lecture in the course. Right? And so I guess that's it for today.